Hey everyone, today we're going to look at a question that asks for sling stress. This is a question you'll likely encounter on your deck safety exam. These are pretty easy if you just follow the progression and know your trigonomic functions. I'll go through them and color code my work. So a sling is rigged on a piece of piping weighing 1,000 pounds. The angle between the sling is 140 degrees and the legs are of equal length. What stress is exerted on each sling leg when the pipe is lifted? So we start with this initial diagram. The sling legs are here and here. The angle between the sling legs equals 140 degrees. So we have our angle and we have the weight being lifted, which is 1,000 pounds. That is step 1 and 2. So our weight is 1,000 pounds and our angle is 140 degrees. Step 1 is to identify the weight. Step 2 is to identify the angle. So pretty easy, step 1 and 2. The third step is to divide the weight and angle by 2. So what that's doing is dividing this diagram into 2 to isolate one sling leg. Right now this diagram represents both. We want to isolate one sling leg. We have to divide each of these by 2. So 1,000 divided by 2 and 140 divided by 2 equal 500 pounds and 70 degrees. So this is going to be your step 3 here. Step 4 is to identify the variable we need and solve for it by drawing a diagram. So what I just did is I separated this full diagram into 2 pieces, one sling leg and the other. So what does that look like? We're redrawing our diagram. The vertical component is 500 pounds because that weight is now being divided into 2. We're still looking for the stress on this sling leg, which is the hypotenuse. And then we have our angle, which we divided by 2, into 70 degrees. So now we just have a triangle. Using our new diagram, so step 4 is here, we've identified what variable we need to solve for. We can use our trigonomic functions. In this case, it would be our cosine function. So cosine of your angle equals your adjacent over your hypotenuse. So now we have 2 of the 3 required, 2 of the 3 givens that we've solved for to solve for our hypotenuse. So our cosine angle is 70 equals our adjacent. The vertical component is the adjacent variable to our angle. So our adjacent is 500 over x, which is our hypotenuse. So now we have our cosine function, we have the givens, we just solve for x. I'll do that now. To isolate your x, we will do x times cosine 70 equals 500, x equals 500 divided by cosine 70 degrees. Now it's a simple calculator problem. So 500 divided by cosine 70 degrees gives you a sling stress of 1,461.9 pounds. That's how you solve the sling stress problem. This is step 5 here, and our answer is D.